Images and registries. In this section, we'll start by learning about advanced options for Docker build and how to tag your own images. Next, we'll learn how to troubleshoot containers and images. We'll then move on to managing images on your local server. Next, you'll see how you can use Packer to build images rather than using Docker build. The last 3 videos will introduce you to Docker registries, show you how to add images to a registry, and show you different options for running your own registry. Advanced build options and image tags. In this video, we'll learn how to deal with cache problems when using a base image. Next, we'll learn how to use Dockerignore files to control what is sent to the Docker daemon to build an image. Finally, you'll learn how to tag your images. Using base images is a great way to get started with a new application image. There can be a problem, however, due to Docker's layer caching. Here's the problem. Let's say you have an image that uses the Debian stretch base image. The first time you build your image, Docker will download the Debian stretch image from Docker Hub. You proceed to do your development and deploy your image. A while later, you need to update your application to make some required changes and rebuild the image. In the meantime, the Debian project has released an updated image to fix a critical security hole. Docker will see that the Debian stretch image has already been downloaded and used that. The problem is that the old version on the host still contains the security hole. One way to fix this problem is to use the no-cache flag that was introduced in video 2.1 when you built your image. This has 2 problems. The first is that all of the build caching Docker does is ignored. That means that if you have something in your build process that takes a long time, it will always take a long time. You can get around that by only using no-cache the first time you rebuild and leave it off later, but that becomes dependent on your memory and is hard to handle with an automated build process. Fortunately, Docker has provided the pull flag for Docker build. When the pull flag is used, Docker will always attempt to pull a newer version of the base image. If you already have the latest version, nothing will happen and your cache will still be valid. You'll still get all of the speed-up benefits of the layer cache. If there is a newer version, Docker will download it and rebuild your whole image from scratch. This is one of the reasons you want to be sure you specify a version tag as part of your from instruction. If you are just using the Debian image and the project released a new major release, you could suddenly find your application attempting to build and run in a completely different environment than what you expect. When Docker build runs, the first thing it does is copy everything in the build context to the Docker server to prepare for the build. Depending on what's in the directory, that can be a lot of unnecessary files. For example, if you're actively developing an application in Emacs or Vi, you may have a lot of backup files that end with a tilde character. There's no need for those to be sent to the server. The same is likely true of documentation that may be kept in the same source directory or source control directory such as .git. Docker allows you to add the patterns of files that you wish to ignore to a file called .dockerignore. The file name is in all lowercase. It must be in the root directory of your build context. The file format is similar to the .gitignore file that Git uses. Docker uses Go's filepath.match rule set here, just like it does for the add and copy instructions. There are a couple of additions. Paired asterisks or star characters are used to match any directory depth. For example, */.git will ignore any file or directory named .git anywhere in the directory tree. You can also use the exclamation mark to exclude any file or files from a previous pattern. For example, you may wish to exclude all files that end with .txt from anywhere, but include a readme.txt file. I've mentioned the importance of image tags several times over the course of these videos. They give you a way of versioning your images. That makes it easy to see what version of your image a container is running, and it makes it easier to roll back to a previous version if you discover a bug in the latest build. There are 2 ways to tag your image. The first way is to do it at build time with the --tag or -t flag. The tag flag takes an image name, which we've been doing throughout these videos, but the name can be optionally followed by a colon and the tag name. Let's start with a simple Docker file. In version 1 of our demo, we'll create a file named /version and put the number 1 in it. When we build the image this time, we'll add the 1 tag to the image name. We can run the container from the demo:1 image and see that /version does in fact contain the number 1. Now let's pretend an update is needed to our demo. This time, we'll set the contents of /version to 2. This time, we'll tag the image as version 2. As expected, when we run a container based off the new image, /version contains 2. The thing to keep in mind here is that version 1 of the demo image still exists. We can still run containers with version 1 of the image and see that /version is still 1. The other way to tag images is with the Docker tag command. Docker tag takes the original image name as the first argument and the new name as the second argument. Either image name may also include a tag. This lets you create an alias to an existing image. You can use this to specify image tags for your workflow. For example, you may have a tag named stable for the current stable image and a dev tag for the latest development release. These types of tags are great for humans working with your images. For example, if you are working with a new image, it may be easier to work with a colleague if you can tell them to pull the latest dev image. Another thing you'll often see is a more general version tag for an image. For example, the official Nginx image tags a specific point release as 1.13.3. However, there is also a tag for 1.13 that always points to the latest point release of the 1.13 Nginx release. Currently, it points to 1.13.3, but will point to 1.13.4 when that release is published. In this example, we'll assume that we want to mark version 1 of the demo image from earlier as the current stable release. This is done by running docker tag. Now, if we run the demo stable image, we can see that /version is 1 because that's what was in the demo 1 image. After testing, it's been determined that version 2 is the new stable release. We can go ahead and tag demo 2 as the new stable. If we run the demo stable container now, we can see that /version is now 2.